Hello, in this video, if I can, I will try to troubleshoot and repair this faulty power bank from MI. It has charging issue, that is the battery doesn't charge and it's been drained all the way down. I will show in a second that the charging plug has been damaged. As you can see, it has a capacity of 20,000 milliampere hour. It requires about 5 volt 2 amps as input. The question says risk of fire and burns, but I will have to break that cautious rule for my own risk and see if it can be restored. This is valuable, you can't just throw it away. Look at this, the charging connector plug has been damaged. Anyway, I'll open up the case. There it goes. Yeah, I spotted something there. I'll zoom in a little bit. Alright, try to align with the camera so that you can see it. Well, it is a transistor, probably the one that is controlling the charging voltage. So, the small transistor has been cooked and already turned into carbon. This, I think, is probably controlling the input voltage and then charge the battery. No doubt, it needs to be replaced. Anyway, I'll continue taking it apart. Zoom it off. Okay, I'll try to desolder the burn components that I have just spotted before. There it goes. Clean it up a little bit. Okay, I have tried desoldering the charging connector plug. Here I'm using a bigger iron because the iron that I used before was a bit small, so it could not heat up properly. So it should pop open now. Alright, looks pretty, man. So I'll hold a new plug. This is a new plug and this is the way it should attach to the main board. Alright, I'll apply flux to prevent oxidation reaction as I'm going to heat. Now I'm going to get my iron. Oh, where's my iron? Okay. I'm going to apply solder and heat gently. So what I'm going to do now is I need to be very careful in soldering these small components. You see those legs, they need to be very clean and pure. Right, it looks pure and clean. So what I'm going to do now is I'll test with my meter to verify whether my soldering is good or not. So I'll probe right there. So I have no beeps or readings, that means it's perfect. Now I'm gonna install a new part in replacement of the one that has burned. I'll align the legs and solder. Right, looks good. I'll rotate. I'll hit the middle leg again. So this has 3 legs. Alright, everything looks good, fit and fine so far. Yes, now that I have replaced both the faulty components, I'll go on for my first test of it. Right, I'll connect the charger. So inspect, nothing is probably heating up, so good. Now I'll test some volts. I have here 5 volt. Oops, 5 volt as input, which is fine. Now I'm going to test the battery charging voltage. It should read 5 volt. But I don't have 5 volt, I have 0 volts. Oh, 0 volt means the battery will not charge and nothing is gonna work. The power bank is still dead. It's just like a piece of garbage at this point. The fact is I've replaced the charging connector and the transistor and have a good input volts but still end up with bad results. So I need to troubleshoot more. So I will check whether or not this ground has the same potential difference with the B minus ground. Simply they should be connected each other because both are grounds. To check this, I'm going to probe my meter. I hear no beep or reading indicates there is no connection. So I will simply install a jumper cable between the two terminals. So I'll apply solder to solder. Alright. I'm going to get my cable here. I'm going to use a regular electric wire for my jumper cable. It makes no difference. So I'm going to solder between the main ground and the B minus the battery ground. It's so small, that's why it's very hard to handle. Alright. Okay, I have soldered. So I'll go for the second test again. Now I should have 4.3. Oh, I don't have constant volts and it is decreasing, and this is not a good sign at all. So we have more problems. Actually, this has to be the required voltage. It does not increase, it does not decrease, it remains constant so far. And this required voltage has to reach here the battery plus terminal, and it doesn't. Now that voltage has been reduced to 3.9 volts again. This voltage from here has to reach this terminal. So there should be connection between this terminal. I'll do the same and install a jumper cable across. Alright, it's done. Now I should have, yes, a constant and appropriate charging voltage. I'm happy so far. It probably might work now. Now I'm going to install the battery bank and see for another test again. Alright, now I will turn the charger on and see. Okay, we have light now. Let's see. No. LEDs are blinking together. This is not the way it should. We still have a problem. Hey, wait. Look at that. I forgot to connect those wires. So I'll solder and see it again. I'll go for another test again. I'll turn the system on. There it goes. Let's do some inspection. No heating, no smoke. Turn it over. Now we have the correct indication. The battery is down. So I'll turn the light off. So the LED should stop blinking and go away. Okay. Turn it on again and should come. Yes, this is correct. Now I will check the performance of the motherboard here. I have 3.846 battery volts. If it is good, the battery volts should increase because it is charging. Let's wait. Alright, I have 3.847. Alright, we have an increment again. And another increment again. So this concludes that the board, everything is working perfectly fine. So I'm going to leave this for a while and come back again. You see, there we have the first level staying on while the second level undergoes charging process, and it should continue. Now I will try putting everything back to order. Screw it up. Now I'll go for one final test. You should see the charging in process. I'll turn the light off so that you can see it. There you see, I hope, the charging light is blinking. So I'll put everything back to cover. Alright, that's it for this video. It's good that we can restore it. Power banks are good to have. The owner will be very happy, and yes, thanks for watching.